All right, so I am recording, and tell me what you want to talk about.
Graphing functions or finding just finding the equation of a function given the
Like
two
when it's like
points.
y equals ab to the x power.
Yeah.
Like
So
if
like
I
I know
give
for
you
like
2 points, like that where one's not the y-intercept, that kind of thing.
yeah.
All right, so okay, well, you know what? Let's do one now. Let's make one up.
I know that today's problem is the fruit fly one has it, as well as like some of yesterday's. So
Right.
yesterday's
Okay.
we start off by using
So
Desmos.
awesome. So what I'm going to do
Yeah.
is I am going to hold on, go in here. I'm going to share my screen, and we will do a problem together, and this should help. Okay. So when you're doing these problems, the thing is you look at it like you're solving a system of equations. Do you remember back in algebra when you guys were doing like systems of linear equations, you would find out where two lines intersect, kind of thing?
Yeah.
It's that kind of thing. So let's say for example, we have hold on. What did she say? I am going to be good. All right, so get here. Let me just type in get here. All right. So, all right. So let's say, for example, we have, let me go here. Can you still see my workspace screen?
Yeah, it's just
Okay, awesome. All right. I'm going to let Sarah in when she's ready to get in here. But let's say, for example, we have something like this. All right. Let's say I'm just pulling this right out of my tuchus. One thing, and I'm going to throw some points on here. So let's say that this is like -6, comma, throw a number at me. Oh, 7. Okay. Shocker. Right. Okay. You like that, Billy?
yeah.
And let's say that this is like 2 comma 1/8. All right. And we're trying to find the equation of this function. All right. That's what our job is. We're trying to find out what the equation is for this. And the thing of it is I already know that if I'm going to be using like if I'm going to be using y equals ab to the x power, I have to find out what a is and I have to find out what b is, right?
Yeah.
Okay. So what we have to do is, the problem is that right now, these are x's and y's. These are both different x's and y's. So they're going to create two different equations. So right now, like if I were to plug in x and y, like -6 and 7 respectively, I would have 7 is equal to ab to the -6th power, right? And we're
Yeah.
going to, who's that? That's Sarah. Here she comes. Good. Perfect. Awesome. And so I have 7 equals ab to the -6th power. And we're going to stop
Two
for a
is
second so I can
equal.
say hi to Kelly. Hi, Cal. Hi, honey. Hi, Sarah Kelly. Hello. You are on mute. But anyway, okay, so I'm talking to Billy, and Billy had a question about a problem like this where I gave you guys two ordered pairs and we had to find the equation of this exponential function. Okay? So for starters, what I said is we're going to create a system of equations. So I'm going to plug -6 and 7 into that equation, but I'm also going to do the same thing with this one over here. So I'm going to have 1/8 is equal to ab to the second power. So I have a system of equations. They both have an a and a b in them. Billy, are you
Yeah.
okay with that?
Yeah, but then don't we have to set like the AB to the
Yeah. So now,
-1?
so now we're going to solve this one for a. So if I solve this guy for a, I'm going to have
7 is equal to
this winds up being 7. Whoops, let me erase that.
7/8, right?
No, that winds up being, I get 7 is equal to, because b to the -6 is over b like that, right?
Yeah.
Okay, so if I solve this for a is going to be equal to 7b to the 6th power. Is that okay? Because I multiply both sides by b to the 6th.
Yeah.
Are you okay with that? Sarah, are you okay with that? Awesome. I don't
I
know why
thought
I can't hear you. I don't know why you're on mute, but I can't hear you, sweetie.
wait,
All
ceasefire.
right.
I thought here though, don't we? I thought from the video, I thought we combined the B's to make it like
Oh, we are.
we.
Well, hold on. We're not done. I solved
Oh, okay.
for a first because I'm going to substitute a. What I got, a is in terms of b right now. So I'm going to replace this a with this one over here. So I have one equation with one variable, because right now, take a look. This has two variables and this also has two variables. So my goal is to get it so I have an equation with one variable so I can actually solve for that variable. Does that make sense?
Yeah. So we
Okay.
just plug it in.
Right. So now we're just going to plug it in. Exactly. So now I have 1/8 is equal to, so now I have 7b to the 6th times b to the
B to the
2nd.
second. Yeah.
Right. And when I tidy this up, I'm going to come on up over here. I get 1/8 is equal to 7b to the
Eighth.
8th power. Good. So now if I'm going to solve for b, I have to divide both sides by
7.
7, which means 8 is going to get multiplied by 7. So I get 1/56 is equal to b to the 8th power. Sarah, are you okay with what I did there? Give me a thumbs up. Give me like a, awesome. Okay. So now this is b to the 8th. So to undo b to the 8th, I have to do
Big root it by 8.
the 8th root. Say it all with me. The 8th root of 1/56. And then the 8th root, obviously this is the 8th root of b to the 8th. So this is just going to be equal to b on this side. But so we go into our calculator. So that's what I'm going to do is we are going to go to our calculators and let me do a new share, and we'll go to my desktop and we'll open this sucker up. Let me hit share first. Okay. So I am sharing my desktop and I'm waiting for this thing to come out. Did Sarah just leave?
No, she's still here.
Oh, you know why? There you go, because I have it where only one person shows. Now there's both of you. Hi, I thought I lost you for a second, Sarah. Sarah, you notice that my shirt, the geometry of my shirt is similar to the geometry of your back of your headboard. Anyhow, I thought that would be entertaining. So can you guys see? I'm waiting for this to open up, my smart view. I'm waiting for my calculator to open up. It's just taking its old sweet time like Mrs. Butterworth. So just bear with me here.
Yeah.
So on your calculator, you do have the option to find out what it is. Oh, come on.
Do you want me to just tell you what I got?
Yeah, just tell me what you get for B.
I got
I want to show you something else on the
0.605.
calculator, which is kind of, what do you get, honey?
0.605.
0.605?
Yeah.
Okay. Sarah, are you okay? You got that too? Awesome. Okay, so we got that for B. So now that we have that for B, so in my equation up top, I now have y equals a times 0.605 to the x power. I have to find out what a is, yes?
Yeah.
So if I want to find out what a is, let's go back to this equation right here. Look at this. A is equal to 7 times whatever b to the 6th is. So right now, if you want to find out what a is, all we have to do is we just have to do a is equal to 7 times
7 times
0.605. Yep, and then raise that sucker to the 8th power. And what do you get for a, honey?
0.126.
0.126. So now the equation here is y is equal to 0.126 times 0.605 to the x power. Now there's some things I want to allude you to, knuckleheads, too, right? Is that this number right here, what does this number represent?
That's the y-intercept.
That's the y-intercept, it is. That's the y, oh, look what finally just popped up, you guys. See that? You see my calculator? Look what finally just made an appearance and said, hey, I'm here. Thank you, thanks for coming. Okay.
So instead of putting it back to the a equals 7b to the 6, can we just do y equals ab to x and then plug in 7 is equal to a times 0.605 to negative 6?
Yeah.
Right.
It should still work.
Yeah.
I just think this is a lot easier right over here.
Yeah, I agree.
You agree with that? Like, we already know, like, in other words, do you remember, like, I'm just saying, like, when you were doing systems of equations, when you were doing it for linear functions, we always went and looked for something where you could just plug it back in where it's super easy. So yeah, so this number right here, I know that this is 0.126. That I know. Okay. All right, other questions that you have?
Could I like run through with you like for today's one and see if I still understand it?
Sure.
All right. So it's I can tell you the points. The points were 2, 100 and then 4, 300.
Oh, this is for the fruit flies, right?
Yeah. The
cocoa problem. Okay, 4, 300. I'll do a different problem like the cocoa problem, but I'm not going to do, I'm going to let you do the cocoa problem, okay? But I will make one up in the process. All right, so if you two want to work on this one, Sarah, are you okay with this one, or do you want to work on this one too? You want to work on it? I don't know why. How come your thing doesn't work? I know you're typing to me. I did it already. All right, show off. Okay, let me see if I can make something up, all right, while Billy is working on his shenanigans. And let's do CE to the KT plus. Let's make the room temperature 72 degrees, all right? So we're gonna be doing something, Sarah, for you. I'm gonna do a separate problem, okay, where you shut it down. So let's say that we have an equation. So this is the one that I put up there, right? So for example, it would be something like this, all right? Where this falls under what's called Newton's law of cooling. So in other words, if the room temperature is 72 degrees and we leave something in there and nobody disturbs it, if something is hotter than that, it's gonna cool to 72 degrees, right? If something is cold, it's going to warm to 72 degrees. It's a beautiful thing, okay? And let's say the initial temperature, let's make this, Sarah, let's make it a slice of pizza, okay? Pizza coming out of the oven is typically like 400 degrees, okay? So let's say the initial temperature is 400 degrees, okay? So the initial temperature is 400, and then 5 minutes later, let's say it warms to or cools down to 310 degrees, okay? I want to know at what time is it going to be, say, 195 degrees where you can eat it and not burn your tongue, okay? You want to be able to eat it and not burn your tongue, okay? Awesome. Because if you try to eat it right out of the oven, you're going to burn your tongue. And how many of you have burned the roof of your mouth? Who's burned the roof of their mouth? Oh my God, it hurts, right? And then you get that nasty skin that comes off too. It's gross. Okay. So Sarah, the first thing that you always want to go with, if I give you an initial temperature, you always want to plug that in, because this ordered pair is T comma Y, right? Our ordered pairs are in the form of T comma Y. You with me on that? So we're going to plug in 0 for T and 400 for Y so we can find out what C is equal to. Because here are the constants. The constants in this equation are going to be C and they're going to be K. And it's the temperature and the time and the temperature are what's going to vary. So our job is to find out what C is, and our job is to find out what K is. And we want to use this information that we have here to help us find who's who, okay? So I would go ahead and use the 0, 400, plug it in here, and then tell me what you get for C. I'll wait for you, okay? So, and if you want, just type it into your chat thing, and then I'll put it in, okay? And Billy, how are you doing?
I think I got it.
How many fruit flies are there initially?
I got 33.4.
Right, so about how many fruit flies?
33?
Yeah, so there's about 33. Do you want to do this
right.
problem with us too? Do you want to do this problem with us too? Like we have a pizza slice here that we are going to eat? Okay. Yeah, it is going to be 33 fruit. It comes out to about 33.
So that's what I was confused on, was when it was like A is equal to 100 over B to the second, I forgot to change it to A equals 100 times B to the negative second.
Ah, yes.
And then
that's those damn laws of exponents, man.
Yeah, so because that, I kind of got confused on how to do everything. So yeah.
Love it. Good. And I'm glad you asked. And the nice thing is I'm going to post this as an extra help thing. So if people have the wherewithal to watch it, they're going to be smart. Sarah, do you have C for me yet? Well, remember, you're plugging in 400 for Y, and you're plugging in 0 in for T. And then you're solving for C, right? So you should be able to tell me what C is equal to.
C-E-K-T.
Yeah, so let's say that we have a room temperature of 72 degrees, Billy.
Yeah.
So this is the equation for Newton's law of cooling, if you want to find out, you know, like what the temperatures of certain things are. So this is, and it varies depending upon how fast something is cooling or warming up or cooling off. So, so we have a room of 72 degrees. So we took pizza out of the oven, and the initial temperature coming out of the oven is 400 degrees. 5 minutes later, the temperature is 310 degrees. And then it's going to be edible where you don't burn your tongue at 195 degrees. So we want to find out at what time is that going to happen. So I always like to say, if I give you an initial temperature, that initial temperature will help you get your hands on C. Okay?
Okay.
All right. So
we
Sarah,
won't solve this.
yeah, we're solving this. We're solving. I want to know, like, how long is it going to take? Like, in other words, by the time this thing comes out of the oven, how long do I have to wait until I can eat the damn pizza? That's what I'm trying to find out. So
couldn't we solve this one the same way as the other one?
No, actually, the reason why is because if you look at this over here, going back, like when I gave you guys something where it was, you know, if I gave you something here, if I gave you the y-intercept, didn't that make life really easy for us? If I told you that this was 0, 10, and then this was like 3,81, something like that, and you did your y equals ab to the x power, couldn't you find a initially?
Yeah.
Right? So you would just plug in the 0, 10. So you would do 10 is equal to a times b to the 0. B to the 0 is 1. So I know that a is equal to 10, right? So then I would just have y is equal to, you know, 10b to the x. And then I would plug in the second ordered pair to find out what x is, to find out what b is. Does that make sense, Billy?
Yeah.
Okay. So now going down over here, like I said to Sarah,
she said that she thinks C is 328, by the way.
I'm going to just go and look at it because it's 400. Yeah, it is. It is 3. Yeah, because here's what you're doing. You're plugging in. I'll use a different color. Let me move this up first. Okay. I can use my different color, my pretty green. So 400 is equal to C times E to the K times 0 plus 72. And let's go back over here. K times 0 is 0. And E to the 0 is
1.
So you get 400 is equal to C plus 72. And then Sarah subtracted 72 from both sides. So we currently have y is equal to, you said 328, honey? Right? E to the KT plus 72. So like I said before, so Billy, look up here for a minute, okay?
Yeah.
When I gave you guys this equation right here, right? Our job is to find out what C is, and our job is to find out what K is, because that's going to tell us about this specific situation about our pizza. So once I have those, we're good to go. But our time and temperature vary. That's what's varying. So the C and the K are the constants, and those are the two things that I'm on the hunt for, okay? So we took our initial value, right? We took our initial temperature, we substituted that in, and we did our magical stuff right over there. And now we're going to take our second ordered pair, and we're going to substitute it in for T and Y respectively. And that way we can find out what K is for Sarah Kelly. All right. So now we're going to do 310 is equal to 328 e to the 5K plus 72. Are you two knuckleheads okay?
Yeah.
All right. Sarah, would you agree we're going to subtract 72 from both sides and then divide by 328? Awesome. Okay. All right. So we're going to do 310 minus 72. And then, okay, so that's just going to be 372, 238. Leave it as a fraction. Don't turn that into a decimal because it'll make it a lot more accurate. Your K will be more accurate if we just leave it as 238 divided by 328 is equal to e to the 5K power. Okay. Are you two Uncle of the Chuckleheads okay with what I'm doing now?
Yeah. Shouldn't we?
That's awesome. You like that I'm calling you Chuckleheads? I know. Don't you miss being in class? All right. This is an exponential equation. So remember, we're going back to that if I have like y equals a to the x power, you can write this as log base a of y is equal to x. You knuckleheads okay with that?
Yeah.
How would I rewrite this as a logarithmic thing?
Log base e.
You could do log base e of
238 divided by 328 is equal to 5K.
Is equal to 5K. The other way that you can write that, by the way, is you could just do the natural log of 238 over 328, and that would equal 5K also. Okay, so either way, it's all good. So, and then you'll do log base, blah, 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 blah. And when you divide it by K, get me 3 decimal places for K.
Log base.
I'm just going to do ln of 238 because it's right there in front of me. And I love the natural log. Natural log is best friends with E. And E is one of my favorite numbers other than 0. Right? And then divide by 5. And you get K is equal to?
Negative 0.0641.
Yep, 0.641. I like that we're going to go out 4 decimal places, actually, Billy. I like that. And by the way, it makes sense that K is negative. Why does it make sense?
Why is it?
Yeah, why does it make sense that K will be negative? Sarah, are you typing for me? Let me go to my little chat screen.
She said it's a K.
C, C is 3, it's a decay. How come it makes sense that this is going to be a decay? How come it make, because the pizza is cooling off. Yes, it's decreasing because it's decreasing in temperature, right? What is the, by the way, what is the coldest temperature the pizza will ever get?
72.
72 degrees, because that's the temperature of the room, right? Isn't that cool? All right, by the way, this is all calculus cool stuff, by the way. Mama Shaw is so happy to be showing you guys this, you know. We actually derived these equations in calculus. I just want to show you that. I just gave them to you because we're in algebra 2. Anyhow, so now we have K. So now we have Y, because of course I'm running out of space. I will erase my little T comma Y over here. You guys now know that we have that equation. So now you guys should see if you can go find that time for me, because I'm just going to type the equation that now we have Y equals 328 times E to the negative 0.0641 T plus 72. So this represents the warming or the cooling off of the pizza, right? That comes out of the oven. This is the equation that it represents. So now I want to know, when is the temperature going to reach 195 degrees?
2.
That's what I want to know. So that means we're going to set Y equal to 195, and then we have to solve for T. Are you two knuckleheads okay with that? Awesome, blossom. I'll wait for you. I want to see what you two come up with, and hopefully you two come up with the same answer. I'm just going to erase some space here so I have it, so that way I can show the work when you guys are done, but I really want you guys to do the work, okay? And then Sarah, something tells me when you go do those problems on your own, you're going to rock it. What do you think? Yeah, atta girl. All right. So we're looking for T comma 195 here. All right. And then, so this is 195. This 0.64. Whoops. 2 zeros there. Double zero because it's taking its time. 641 T plus 72. Did you guys subtract 72 first?
Yep.
Good. Did you guys divide by 328 after that?
Yep.
So we have 123 over 328 is equal to E to the negative 0.0641 T. And then again, we could do log base E, or we could just do the natural log. I'm going natural log because I just love my ln. 328 is equal to negative 0.0641 T. And then I'm going to divide by that. And then let me know what you, my little friends get. ln of
I got 15.
123. So I want to make sure Sarah's got it too. All right, divided by negative, whoops, that's a minus sign. I will get an error if I do that, 0.641. And
15.3.
15.3, Sarah? 15.3 what?
Minutes.
Minutes. I'd rather burn my mouth than wait 15.3 minutes.
I'm just most surprised that it's still 195 degrees when you eat it.
Well, some people are, I don't know, I don't think 195 is that hot. Because I've
I
eaten
can't
stuff
tell.
I've eaten stuff right out of the oven. I've eaten stuff that's like 400 degrees. Now, granted, I burned my tongue, but I'm not waiting for it to get to 195 before. Like, I can't wait 15 minutes. You know,
Yeah.
I wouldn't. I'll burn my tongue. I'll deal with it. I'll deal with the pain. Right? These were two
So
amazing questions you two asked, by the way.
so did we even need to know the 5-3? Oh, we didn't need to know the 5-3-10, right?
Yeah, we did. What was
That's
right? Because
okay.
the 0-400 helped us get who?
The that helped us get C.
Yeah, and then the 5-310 helped us get
K.
yes. So when you
Okay.
go and do your cocoa problem and stuff like that, and I know Sarah's going to rock it, you are. That's basically, you're always using any information you can to find your variables, because remember, the C and the K are constant. So, and it's just that the T and the Y are what vary. So in other words, the temperature of the pizza depends upon what time it is, but but the C and the K are what remain constant. Okay?
All right.
Sarah looks like she's typing something.
Just so when we graph this, would that mean that the asymptote would then be 72
Yes.
because it can never go below it?
Yes. Yes.
Okay.
Yes. 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 All right. What does this knucklehead say? Let's see what she's got to say. So for the cocoa, it says the hot chocolate is 95. Yes. So the first point would be 95 degrees. Right. So that's the initial. That's your initial.
And then the other point would be 185 then, right?
And the other point would be 1,85. And then I asked, when is it going to reach 50 something degrees? Is that right?
So it'd be, yeah, 51. So it'd be T, 51.
By the way, was that in degrees or Celsius?
Celsius? Celsius.
Celsius, by the way. So just so you know, it's not 95 degrees Fahrenheit. It's actually, so it's much hotter, because 95 degrees is not that hot.
Yeah, that's nice to drink.
But if you do Celsius, it's 9/5 C plus 32, or you double that number and add 30. So technically, I'm just letting you know that if you do 95 degrees Celsius, 95 degrees Celsius is about, oops.
220.
Yeah, it's about 220 degrees, okay? So just so you know, because it goes back to, just remember, Celsius and Fahrenheit is different. Remember, in America, we're Fahrenheit people. You go overseas, all of a sudden, everybody's in Celsius. So if it's 10 degrees Celsius over there, it literally means it's 50 degrees. 10 degrees here, Fahrenheit is freezing, you know?
Yeah.
Yeah. Okay. Do you guys have any other problems? I'm going to stop sharing. I think we can stop recording. I think we can stop recording. Are we good?
I mean, we're good.
All right. You guys are amazing. I'm around for more questions. You guys should be helping other people. That's all I'm going to say. You're amazing. I love you both so much. I'm going to hit stop recording.